Okay, I'm Ethan Davis, and Tom Berlidis will be speaking later in a recording. So I have four co-conveners. Tom is the only one who is also presenting, and none of them could actually join us today. So just me here. And they're the experts. I'm just like the was too curious. So welcome. Is everybody familiar with WMO and those things to some degree? Well, I'm going to talk about it anyway. So I'm going to give a little overview of WMO and WIS2, and then Tom's going to give a talk on kind of the bigger architecture, standards, technologies, go into some details there, and then give a demonstration, all recordings, and then we can talk, and I can try to answer questions, and I think I can reach Tom on a chat or something if I need a more in-depth question, but but I've been talking to them and talking about it and looking into it for a while, so hopefully I'll know some answers. So, all right. So WMO is a specialized agency of the UN. It consists of 193 WMO member states and territories. And it was formed in 1950, but it was also preceded by the International Meteorological Organization, which was formed in 1873. So it's been around for a long time. WMO's main thing is to promote international cooperation around atmospheric science, climatology, hydrology, everything, all the earth sciencey kind of things, and coordinates free exchange of data across all the members. So that is what the WIS2 is about, and we're going to talk about. So their goal there is to, have enough metadata, have enough data to monitor and understand and predict weather and all sorts of things. So, and improve our forecasting abilities. So there's WMO, and this free exchange of data has been going on for a really long time, even before IMO in some respects. And I don't know, I just watched the movie Pressure. Has anybody seen that or seen the trailers? Just came out. It's Brendan Fraser and I can't remember the guy's name. Anyway, it's about weather forecasting for D-Day in World War II. And it's really interesting. And anyway. So I just watched it on the plane coming here. So it kind of made some connections there with this session. Right. So as I said, data exchange has been going on for a really long time. Telegraph, and even before that, there were, people talking about weather and recording weather things and sharing it as they could, letters probably. So it was a little late to get forecasts, maybe. But telegraph went in. They definitely were exchanging weather data, and then the teletypes in the 1920s. And then soon after, kind of the first weather satellites were launched in the 50s and 60s, this World Weather Watch kind of started up. It was just a program to oversee, all of this. And it came to include all the observational systems and the communication of that data, so the exchange of the data, and also analysis and prediction, so forecasting, modeling, and all that kind of thing. It still is kind of the overarching program, World Weather Watch, and it now the communication part is currently the global telecommunications system. It started in the 1970s, and that's kind of a distributed direct connections to different sites and exchanging the data. And I guess another thing, this 193 member states and territories, all different capabilities and levels of sophistication in terms of the technology they have. So it has and still has to be accessible to all of these different levels of capabilities. And there's a lot of efforts to improve, help different countries increase their capabilities in this respect. And so all of that is kind of figures into the minimum requirements for connecting and for the data that's available. So in 2007, WIS 2 came out. And I'm going to, sorry, WIS, the first WIS, it was kind of, they were trying to redo some of the technology, but it continued to use the GTS, and it was a layer on top. And it, I don't actually know what parts of the system it actually improved. I just don't know that much about it. So, but that happened a while back. And then WIS 2 is happening now and kind of officially started launching. I have a timeline later in the talk about when the different phases of WIS 2, but that is ongoing now, and we'll talk more about it. Okay, so I'll talk about that right now. The thing that isn't on here, but I'm going to talk about in this unified data policy is the current policy for all of the WMO. Free and unrestricted exchange of data, near real time, and also archived. So observing systems, in situ, radar, satellite, analysis and prediction fields. So all the modeling, numerical weather prediction, and then and it includes all the different, WMO has this set of disciplines and domains that they are focused on. So now I'm forgetting the year, maybe it was 2021. Oh, it says right there, 2022 for this unified data policy was agreed. In 2020 or 2021, they agreed on a Earth system focused strategy, I guess, of things, because it had always been meteorology was here, climatology was here, hydrology was here. So it was very siloed. And that decision was, we need to break that down. So that's where a lot of this comes from. And these disciplines are all of them that they're focused on now and going to be sharing and exchanging the data. So weather, climate, space weather. So that's, I don't know if that's completely new or if that was like a separate part of WMO at some point. So this policy includes some descriptions of core and recommended data. So the core data is things that everybody they have to supply this data, and it's defined in this document. There's all sorts of annexes about it. It's basically WIGOS is everything that's in WIGOS. There's GBON, the Global Basic Observing Network. So there's all of this is defined in lots of different documents, and all the different member states have systems that support all that and take measurements and for those different networks. So yes, and all this data. So right, the main focus is that it's necessary for the protection of life and property and well-being of all the nations. So that's the core data, and that is publicly available. So it has no restrictions on it. Recommended data is another layer that can have restrictions on it. And it's just an extra layer of, so not just protection of life and property, but support more of the monitoring, prediction activities, all sorts of efforts to go into that. So that's where the recommended data comes in, and the member states can decide if that data has restrictions on it or not. So there will be, or can be, some restrictions on that. However, it does say that all the members should provide all of that data for free for research and education. So it's kind of opens up a door to make it a little more accessible, but they can have limits on it. So you can have it, but you can't use it for commercial or for 24 hours, you can't use it for this or that. So there's different kinds of restrictions they'll have on that. Okay. So I mentioned WIGOS, and so there's, ground and upper air and buoys and radar, weather radar, and then satellite imagery. So there's all sorts of stuff in the core, and then the extra. Then you kind of have to get into the details to know what's going to be in the recommended and what goes in the core. So, okay, so that's WMO, data exchange, and their current policy, and what kind of data is in there. And then WIS2 is the new system that is going to support that new policy. Right, it covers all those domains and disciplines. It simplifies the data exchange. It's open standards, mostly OGC, Open Geospatial Consortium standards, if you're familiar with that. And then it will be very cloud native-y, cloud ready. So I'm not good. Tom's going to get into the architecture, but there's different services around the globe, and the global services are running in cloud platforms and AWS and other things. So they're highly efficient, highly optimized, and they'll be highly available. So, okay, WIS2 is currently operational, and the plan is to phase out the GTS, the Global Telecommunication System, that has been going since the 1970s in various forms, I guess, or evolving. Is supposed to be phased out by 2033. So, in WMO time, that is really soon, and really for researchers who have been working in the field and are used to all their tools and all of that. That's pretty quick too, and I think it's the responsibility of all the technology people to make sure that it's a smooth transition. And that's why I wanted to have this session and start talking about it more. So, because there's a lot of work to do, a lot of new standards, a lot of changes to how this particular real-time kind of data and some of this other, so the archive data or the longer term data will be climatology information, a lot of climate records and indices and going back however long. So there's all of that will be available through this system as well. There's both a catalog, there's a pub sub kind of notification of data that data has become accessible. So that's the real time part. And then there's also a data catalog and a data searching capability. So that will be for all of that. So there's a lot of things for this data. I think it's really interesting to think about how this will impact the community and how it will impact all the tools that are being used to access data currently. So, okay. And okay, right. I mentioned this. Right. This is the timeline. And yeah, we've been going through different phases for a while, and have transitioned to operational at this point, though not in every country. I believe it's still kind of spreading. And then by 2030, yeah, it says 90% of members will have migrated to WIS2, and in 2033, stop transition of GTS. So that's the plan, and we'll see how well that goes. Well, I mean, yeah, it seems like a ways off, but things change really fast, and yet they take a long time. So, okay. Whoops, went the wrong way. Okay, that is kind of my introduction overview. Any questions? Comments? Okay. Okay, good. Oh, wait. We have one question.
My name's Andrew and with the USGS. So you mentioned PubSub as a part of the WIS2 implementation. I'm curious if you could elaborate on the standards you're using for that, as well as the technology, if possible.
Yes. Tom is probably going to talk about a lot of this, but I'll just answer now. The standards are OGC standards, and it's OGC API records and API features are kind of two metadata-y focused things that have all the information. And so there's some pub sub connections there with those standards. I will also mention OGC API records is tightly integrated with Stack. And their Stack is involved here too, even though they're close. Right, the records is used for some things and Stack is used for others in the WIS2. But the underlying technology for the pub sub is MQTT, and that's what is used underneath. But OGC records and a few other of the OGC standards build on that for pub sub. So there's a little, different layers of, I guess, MQTT is the software connections and things that actually do the communication, and the OGC records and Stack and whatnot are layered on top of that as the metadata that you're moving around. And I don't exactly, we'll see if Tom talks more about how the actual pub sub works, but there's a bunch of different pub sub capabilities in different OGC APIs. So it's somehow involved in those two layers. Does that kind of answer your question? Okay, perfect. Thank you. And now,
by all the components of this to be able to produce data to a certain data set, as well as consuming and downloading data. So think of the public hierarchy as a radio station that you can tell the data consumer can subscribe to and be able to download data on notification. So this is the idea of the WIS2 topic hierarchy. It is used again, but all of the WIS2 components and services, and is basically the heartbeat and the epicenter structure of how data gets slaughtered and categorized with regards to publish and subscribe. WIS2 discovery metadata. This is obviously data about data. With a focus on data sets or collections. The WIS2 discovery metadata standard is called the WMO Core Metadata Profile version 2, the WCMP2. It is a profile of the OGC API records, standard, specifically the record core component. So there's a base format for metadata in OGC API records that we extended in profiled in WCMP2. Be able to give us those WMO specific defeat WMO specific requirements, as well as broaden probabilities for core OTC standards.
So, as with most metadata, there are core properties or packages to do with identification, extents, data policy, as well as obviously access links. And the standard in and of itself is by nature extensible. So as a data producer or data publisher, you are able to add additional elements to WCMP2 without breaking compatibility or compliance to WIS2. The other metadata standard is a WIS2 notification message. So this is basically hand in hand with the WIS2 topic hierarchy from a publish and subscribe perspective. This is a notification payload which is based on GeoJSON. So this could be advertising a new data set on WIS2 or advertising a new data granule based on a data set in WIS2 just the same. So basically, the data publisher uses the topic hierarchy and the notification metadata to publish a notification of their new data set or new data granule, and a data consumer subscribing to that same topic would receive this WIS2 notification message, or WNM, in GeoJSON format, in a specialized GeoJSON format, and be able to download the data associated with that. Let's talk about global services, which are a core part of WIS2 with regards to high availability subscribe, notify, download, and discovery services. So the first one we'll look at in terms of global services is the global broker. This is a notification service on a global scale, and it provides notifications of all data available on WIS2. It is subscribed to all of the WIS2 nodes in the network, as well as all of the global services, and it basically relays and notifies all users of any activity with regards to new data or metadata on WIS2. It is based on the MQTT protocol, either version 3.1.1 or version 5. The latter is preferred. The global broker and the MQTT service implements a topic structure, which is the WIS2 topic hierarchy, and provides the payload in the WIS2 notification message format, or the WMO, which is basically the GeoJSON encoding. So publish subscribe starts here at the global broker for discovery of all data on WIS2. Next, we have our download service, which we call our global cache. And the global cache is basically a CDN providing a copy of real-time and near real-time data from the various WIS2 nodes in the network. It's based on HTTP or HTTPS for that matter, and it also has its own broker. It's important to note that WIS2 itself does not prescribe any actual data formats or encodings. Those are specific to the community and your system discipline. So WIS2 is all about the pipes, and it can handle any data format or any data encoding or representation. So the global cache basically downloads data from data publishers and makes it available on a global scale. The minimum requirement for data retention for a global cache is 24 hours. In addition, we have the Global Discovery Catalog, or the GDC. This provides a discovery and search capability of all data sets on WIS2, and it does that through the OGC API record standard. So it's really a catalog / search capability, which allows for a Yellow Pages style gateway into WIS2 data and services, and it's given that it's OGC API, it allows for mass market search engine integration quite easily. The API itself, again, is based on OGC API records, which is a broad standard, which is upstream of WMO and WIS2 standards. So the good thing about that is that we have very broad interoperability. So here's a screenshot with QGIS, for example, which is opening up the WIS2 Global Discovery Catalog, and it does not know anything about QGIS, does not know anything about WIS2. QGIS does not know anything about WMO. But the fact that we're using a broad interoperable standard from OGC in WMO and WIS2 allows us to get the easy integration to be able to discover resources on the network. We also have a global monitor, or a GM, and this is basically capturing information on data availability, as well as monitors performance of the various WIS2 components. There's a dashboard capability attached to the global monitor, which demonstrates a number of metrics for global service and data providers in WIS2 to get a better idea of how their services are performing with regards to the WIS2, the obligations for WIS2 as per the WIS2 manual. And this is based on Open Metrics, which is an open standard for providing metrics information on a given service. Here's a blueprint of how it's all put together. I'm not going to go through this in detail, but it's here for reference. So basically, the entire system is based on publish and subscribe. There's no specialized access, if you will, from one broker to the next. Basically, brokers are clients are subscribing to brokers, and no one broker or service is writing to another service. It's relatively read only, and that is basically the mode of how publish subscribe is working in WIS2. And you can see all the different components that were just described and how they all interact with one another. So at the core of it all, using WIS2 is as easy as publishing your data from your WIS2 node. It can be either core data or recommended data. Then from there, on the other side, as a data consumer, you search the global discovery catalog for data sets of interest, whether they be numerical weather prediction data sets, whether they can be observations or um, space weather data, what have you. So you search the catalog, and that's basically your find function. You find a record that's of interest, and you find that record has subscription capabilities through MQTT. So once you find a data set that you're looking for or a data set of interest from the catalog, you subscribe to the global broker for any new notifications on that data set. The global broker, when it receives a message from a WIS2 node that a new piece of data has arrived in WIS2, automatically that data is cached if it's core data for a minimum of 24 hours. So you can see the global cacher, or CDN, is downloading that data and making it available in a high availability fashion. So then the user from that perspective is downloading this core data from the global cache without having to go directly to the WIS2 node, thereby streamlining the publish, find, bind, and download capability for core data. For recommended data is not cached, and all downloads for recommended data are going back to the infrastructure of the data publisher or the WIS2 node itself. Here's our current complement of the various WIS2 services, whether they're brokers, caches, catalogs, or the global monitors. A couple notes around standards. So you can see all the different components listed in WIS2, the protocols and interfaces that they support, as well as their content and encoding. So heavy use of standards here from OGC, W3C, and IETF. And more specifically, you can see component by component how we've implemented how we've added and leveraged many of these standards, which a lot of them are based on OGC, and specifically the OGC API efforts that have been going on since 2017. So heavy use of OGC in WIS2, which again allows us that broad interoperability. This didn't happen by accident. There is a memorandum of understanding between OGC and WMO that has been around for quite some time, numerous years, and this is basically the fruits of this MOU in action to be able to lower the barrier to weather, climate, water data using open standards. So the good work that's done in OGC, the good work that's done in WMO is integrated here with regards to WMO leveraging OGC standards to use them directly or to profile them accordingly. And this is a big part of WIS2, and it was a big part of allowing us to get up and running in a timely manner. Onto the implementation and technology side. In WIS2, we've defined the architecture, we've described the architecture, we've described the standards that are prescribed, and the actual implementations now. Obviously, you can implement anything you wish in WIS2, any component or your WIS2 node, or if you wish to implement the global service from a software perspective, it can be free and open source software, or proprietary or commercial software, just the same. So it's the standards that are key here. How they are implemented is an implementation detail, as long as they're compliant. Having said that, there are numerous FOSS implementations in the WIS2 ecosystem, especially with regards to supporting containerization. So WIS2 is one of the principles is cloud ready and cloud approaches. So number of tools in WIS2 are developed in a containerized fashion. So you can deploy various WIS2 software, free and open source software, using Docker or Kubernetes or any cloud capable service that you wish. There's a sampling of tools here in this list. So one is called WIS2 Box. That is, I guess, our flagship reference implementation of a WIS2 node that helps users get up and running. There are currently 60 or 70 WIS2 Box installations around the planet that are feeding operational weather data in real time. There are a number of other free and open source FOSS implementations. Most of them are global services, as well as some clients and metadata compliance checkers and KPIs. Because of the heavy use of standards, we're also using standards-based software out there that across these tools. So Pygeo API is a Python reference implementation of OGC APIs, and it's being used in the catalog implementation, reference implementation, as well as the WIS2 grep reference implementation, as well as the WIS2 node. So heavy use of open standards and heavy use of open source, just the same. What's next? So forthcoming changes that will be introduced at the next Infrastructure Commission session, that's INFCOM 4 in November, will be the concept of a global replay service. So this will be an API and a streaming service of past data notifications. The nature of PubSub is that if you miss a notification, how do you go back and find that notification or replay it, if you will? Global replay aims to cover that need and use case. We also have introducing the concept of sensor centers, which is external functionality or health check functions, so that global services can be assessed and improved over time. As well, there will be a number of exercises on APIs. We don't say very much about APIs in WIS2 currently. However, we will be working on recommendations for APIs for access visualization, processing, and so on. This will be centered around the MedOcean profile work of OGC APIs that is going on in the OGC MedOcean domain working group. So we're defining a MedOcean common baseline for naming conventions and vocabularies. From there, we will define a MedOcean profile for mapping or visualization, OGC API maps, MedOcean profile for EDR processes. You get the idea. Wiki page is there. We're also looking at working on hypercube description metadata for multidimensional data cubes and how we formally describe those through the technical regulations.
Okay. Let's see. Okay, any questions about that? A lot of details. Yes, Sean. Oh, good job. Good job.
Yeah, you were on it.
John Ralph, NCEI. Can I assume that the global cache just uses HTTP or HTTPS? Can I assume then the requirement is that the individual centers have to do the same for recommended?
Yes. So the national centers will, for recommended data, they will be responsible for what the cache would be doing. So downloading and discovering it and access to it through download currently, and then the new stuff that's being added in the coming however long, the API access to them. So yes, that is my understanding.
Hello, this is Sean Smith. Can you hear me?
Yes, go ahead.
I had a question. I threw it in the chat. Is there any plan for the WIS2 architecture to integrate with ERDAP, an ERDAP data backend?
I would say no at the WMO level, and I'm not sure there is at the U.S. Weather Service level. I think that would be something that may be a service that somebody would need to supply separately. So, you could, I'm not sure how one would go about getting that type of service added, but I think the other option would be to subscribe to the data that you're interested in being available, and then using and bring it somewhere where you would then serve it, or point an ERDAP to the access points for the data. I guess the question is, how would ERDAP handle a real-time flow of data that is only guaranteed to be there for 24 hours and it will go away? So that might be hard to do as a separate service, but there might be some connections you could make, and working with the Weather Service, the U.S. Weather Service, or whatever National Weather Service, in terms of where the global cache and that kind of thing. And then, of course, the recommended would be you'd have to go to wherever the data is coming from and talk to them about it. John,
so I'm thinking of this from a very different perspective. I'm thinking of not pulling data from WIS and putting it into an ERDAP. I'm talking about having a globally distributed system of ERDAP services that actually feed data into WIS. As I understand from my knowledge of WMO and IOC, there's a big push within, especially the IOC, to move toward ERDAP services for global ocean weather data sets, not just in the US, but internationally. So when you're thinking about developing API services, I think there's a lot to be said for figuring out how to have WIS and its brokers pull data from an ERDAP server in real time for feeding into the international WIS distribution.
Right. Okay. So I will say I'm have known ERDAP folks for a long time, but I don't know the current developer, but I know a bunch of the people who are involved in kind of the steering groups or whatever they are for ERDAP. And ERDAP has some WIS2 capabilities. It has MQTT capabilities, has been added to ERDAP, but I don't actually know what that means exactly and how that would be used in this situation. But I assume it is part of them starting to prepare for WIS2 type interactions. So I'm not clear on how that would work, but there's definitely a few things. So I know ERDAP has been used to push data to the GTS currently, which in the US would go through the Weather Service or the buoy center, a data center, and get pushed into the GTS. And so ERDAP has been used for some of that. And a lot of those pathways will continue, I believe, to be available. However, the WIS2 node is kind of, and that technology is the other way that people could move to. So that is probably what the MQTT and other integrations with ERDAP is about. So I'm not sure where that's going, but John keeps nodding, and so he either agrees or wants to correct me. So I'm going to, if you still have the mic. And thanks for the question, Sean. Thanks.
Yeah, John Ralph, NCEI. Yeah, and I was thinking about it. So yes, ERDAP is used to push to the GTS currently, and so I'm going to assume, as you do, that ERDAP will continue to be integrable into WIS2. But that's not. I was thinking more about maybe where Sean's question is coming from. How does a user of WIS to find out that ERDAP capabilities are available and then connect to those capabilities to use the data that WIS2 is notifying them of through the message queue?
Right. I believe that the messaging will contain information about services for accessing the data. So currently it will mostly be the download points. But in the future, as new services get added, the API level stuff that Tom was just talking about, that will be added to the metadata that you get as a notification that the data is available in the pub sub kind of framework. And also in the discovery in the catalog, you get the same sort of thing. You get, description of the data set you're requesting, and the access points would be in there somewhere too. So I guess I wanted to say the WIS2 node should make publishing for people that have data and are running networks and whatever, and some of them using ERDAP currently to push it through to the GTS through NOAA, through Weather Service, wherever. That may be able to continue, but yes, then there will be this other. Each site could run their own WIS2 node to make the data available. They have to get approval and go through all the paperwork-ish, whatever you call it, process of getting approved. But so there's kind of going to be, for a while at least, two options for that data to flow in. Yeah, I think I'm rambling all over this topic. So, but Sean, did that kind of answer your question, or at least give you hope that something might be?
Yeah, no, absolutely. This is something that our data center has been considering. I've been active in WMO for 30 years. But obviously we aren't feeding data to the GTS. That just isn't possible through the architecture we have. But establishing a WIS2 node with an ERDAP backend is definitely something we could do. So now that we have a better idea that the WIS2 software is in a better state, containerized, installable, that kind of thing, yeah, we can start looking at maybe moving in that direction. Yeah.
Right. Great. And Sean, I'm going to ask, where are you located? What?
Oh, sorry. Yeah. I run the Marine Data Center at the Florida State University. We focus in basically research vessel, marine meteorology data.
Right. Okay, great. Thanks. Any other? Okay, yeah, one more question in the room.
Hi, Rebecca Hudak from Hui. I have kind of like a two-part question. I have data and I would like to go to WIS2. How do I do that? Who do I contact? And two, with the transition, do you have plans for like workshops and like introducing it to these other 195 folks to really get them in and have like those how-to guides?
I don't. I'm not involved in the training and stuff, but the WMO folks. So, okay, I'm going to step back 1 second and say, in my first or second slide, I had the title and my name and Tom's name, and I forgot to. I was going to say, and I should just add it to the slide. There's 3 other conveners for this session. Jeremy Tandy, who's at the UK Met Office and also does a lot of WMO work, and is one of the IT architects for WMO and whatnot. Chris Little, who's also at the UK Met Office, and Steve Olson, who's at the US National Weather Service. They're all co-conveners. We all kind of collaborate on this, so I'm definitely going to add them to the slide before I post it somewhere too much. But they're all more involved on the WMO side than I am. I'm more of a user side of things and data distributor and whatever. Anyway, so back to your questions. They are doing a lot of training for the different member states and working to spin things up and help people get various parts of this started. Tom had a slide that listed where the different global services were. It's like US, France, Brazil, China, and a few others, and different. They run different global services, and so the global services are kind of taken care of to some degree. I don't know if they're planning on adding more, but then each member state can run these WIS2 nodes to publish data in, and then I'm not sure how they deal with the recommended data if they have to then run their own kind of version of the global service, even though it's not a global service, it's a local one. So I don't know all the details about how that would work, but they're definitely working on training for all of that. So there are training materials. I don't know how easy they are to find, and that's something I should ask my co-conveners and get more information on. And your second question was, or your first question actually was what? You have data. Who do you contact to get it in? And you're at Woods Hole. Okay. Well, the Weather Service is the main WMO U.S. contact. And so somebody in Weather Service, somebody in NOAA, I mean, NDBC has been doing some of this stuff too, but it's kind of going to be, it's centralized in that the access will be decided somewhere, but the technology can be more distributed. John has a response as well, I think. I'm just glad he's in the rooms to answer some of these questions.
Yeah, John Ralph, NCEI. Yeah, historically, as Ethan says, everything has gone through the Weather Service. They are the lead for WMO in the US. And at NCEI, we were connecting to their node to advertise our data in WIS1. The Weather Service has definitely taken the lead on WIS2. So at the moment, I'm unsure how us distributed data producers and data clients are going to hook up to the Weather Service node in order to do the things we want to do. So what I'm saying is I don't know yet. This project is kind of just getting underway at the Weather Service, as I understand. But it's a really interesting question, and I think we need to include this on our discussions, just to think about what will this mean in the future, and can we streamline getting data from the ships to the network?
Can I?
Becca, also, Sean Smith had a message for you in the chat.
Yeah, no, I can read it.
Yes.
David Berry. Okay. Oh, because I had to contact Kevin O'Brien, but then he moved, and I don't have his most recent email. So, yeah.
So I think, yeah, he's a WMO contact, but I think for authorization to connect to, you probably have to go through the Weather Service still to get the authorization, but then your node that you're running would be connected, or it would be the information about it would be given to one of the global caches, and they would then pull information, or you would be pushing information to them. So I think that's part of it. Were you going to ask another? Okay. One more question. I'm just going to, I feel stuck up there, and so I'm going to walk around.
Gianvilla Militaro, Nestis. So my question is, in Nestis, we produce a lot of data that we provide to the National Weather Service as the user. How do I know if that data is WIS2 compliant? Like, I'm new to this, and all I'm hearing is that I should inform myself more, because it feels like all of this is interconnected, and I need to know more. So how do I know if my data, the data that we're providing to the National Weather Service, is WIS2 compliant, in order to get ahead of of this release when the GTS gets taken out in 2033? And if the National Weather Service is the main, as you mentioned, the WIS2 node, they're the user of the data. So I guess Nestis provides data to the user in the National Weather Service. So I guess I don't know where we stand in that whole network of information. So anything that you can provide insight, I would appreciate it. Or if someone else knows, I would appreciate that too.
Okay, I'm not exactly sure, but are you already sending the information in the GTS? Is that? Oh, okay. So
How do I know that I'm like the data that we're producing to and giving to the National Weather Service as our users, how do I know if that data is WIS2 compliant? Are there checkers? Is there metadata? I saw that there were some tools in the presentation, but I never used those tools. So, like, how do I know?
Was it part of the demo? No, I'm sorry. That second, did I already do the demo? I didn't do the demo yet. Okay, I've like taken all these questions. I forgot. Maybe we'll find out, but I would say that, so the kind of standard WMO things are GRIB and buffer for weather, but he already said that the format depends on the domain that you're in. So like space weather might be something else. What are the other ones? Anyway, GRIB, buffer, CF, NetCDF is now becoming more standard in the WMO and distribution. Oh, and now I'm. Because I like to roam around, I guess. Okay. Okay. Unless there's any more questions, I'm going to move on to the demo, which I would have completely forgot about. So thank you. No, I already did it. What do you mean? All right. Hopefully that's good. Okay. So now we're going to another recording from Tom, which will demonstrate some of the different services and whatnot. So, okay, here we go. Oops, missed the button.
WIS2 in action. So the first thing we're looking at here is a global discovery catalog. It's running from Canada as part of the Meteorological Service of Canada, and this is essentially an OGC API records endpoint that's powered by PyGeo API. So because it's an OGC API, I can scan it for all the different collections that might be on the server. So here we find a record collection, which is called WIS2 Discovery Metadata. And this is essentially the WIS2 Global Discovery Catalog. So here we can see, if we want to browse the catalog, there's over 500 data sets currently, and you can search the catalog temporarily. So we can search for observations, for example, or we can search for hydrometric data. Just the same. So it has, as you would expect from a search engine type API, from a search API, that you would get the ability to do like a Q equals type search. You can also do temporal searches for the metadata and the time span that it covers, so start dates and end dates. You can also, after you discover your data, you can evaluate it and see if the data that you're looking at is something that you're interested in. So if we did we'll do a blind search here to get all the records back, and let's take a look at some of the data sets that we have. So here's some weather elements on the grid based on our high resolution model here in Canada, and we can see that this is the discovery metadata record, or the WIS2 WCMP2 record for this data set. This is just a plain HTML view because the OGC API standards allow you to do this kind of thing, but machine to machine, we're really looking at this GeoJSON here that comes back as the catalog record, and this is essentially the WCMP2, which is modeled after the OGC API records record core requirement around metadata. So typical GeoJSON, we have some added bits on conformance and versioning, and then we can see the usual suspects in the metadata records, such as title, description or abstract, theme. So these are sort of qualified keywords that are able to use it, so long as you have a thesaurus or a controlled vocabulary that is associated with those keywords. There is also other elements for citation and formats and representations. Obviously, contacts, so you can have one-to-many contacts in a catalog record, and each contact can have one-to-many roles, just the same. Free-form keywords, or bare keywords as we call them. A couple of elements with regards to WIS2 itself. One is the WMO data policy, whether the data set is core data or recommend the data, and obviously the link. So you can see we have links to this data through in Canada through our API or through PubSub, which is what we provide with regards to our WIS2 obligation, as well as other linkage mechanisms, such as the landing page or going to the actual license of the data, and so on. So this is basically the data set, a data set description. And if we take a look at the data set description through the UI, we can see a button called Subscribe to Data Notifications, which will allow us to have notifications from each of the configure notifications from each of the global brokers to the PyWis PubSub tool, which allows you to update a YAML configuration with these broker and topic values. And there's even a convenience button here to write it out for you, so you can copy that value and paste that into your PyWis PubSub configuration just the same. And then you'll be able to automatically download data on demand. Next up is the WIS2 downloader. So the downloader allows you to search the catalog, view, display, and evaluate records of interest, and subscribe to data sets of interest just the same. So if we go to our catalog view in the WIS2 downloader, so just to provide a bit more information, WIS2 Downloader is supported by a WMO Secretariat, and it's available on GitHub. In fact, all of the tools that I'm showing here are free and open source and available on GitHub just the same. So back to the downloader, let's search the catalog for real-time hydrometric data. We do a search. We see one record come back for our real-time hydrometric data collection here in Canada. So if I wanted to see what that looked like raw, again, that's the raw GeoJSON. If I wanted to look at licensing information, then the metadata allows us to specify licenses, obviously. Here we're pointing to the MSC Open Data License. And what we can also do is be able to subscribe to data once we hit select. So if we click select, we accept the license. And from here, basically we set a directory that we would like to save to. So I want to save that to /temp. So this means I'm interested in this data set, and any data that comes from this data set through PubSub, I want to be able to download it. That's exactly what WIS2 Downloader does. So I want to save it to /temp. And I know that these are a number of small files, so I'm going to click subscribe, and I have a confirmation window here, which confirms my subscription. So we can see here that I want to subscribe to this topic on the WIS2 broker, cache WIS2, and so on. So that's the first line of that JSON, which is the topic key. So by subscribing to this topic to the global broker, you are then able to receive notifications against that same topic with GeoJSON payloads, which are pointing you to the actual data. So this is some configuration information in WIS2 Downloader, and I'm able to click confirm. And suddenly in the back end of my system, I am subscribed to that topic, and any new notifications that come in through that topic, I will receive notification of them, because that's what I've asked WIS2 Downloader to subscribe me to. And finally, in terms of future state or next steps in WIS2, we did discuss there would be work on APIs and a lot of MetOcean profiling of OGC APIs, such as maps, EDR, and so on. So I have a small demo here of a default PyGeo API instance, which is an OGC API reference implementation. So if I click on all the data collections that are associated with this PyGeo API instance, you'll see that there's a GDPS collection, which is the global deterministic prediction system from here in Canada. This is an EDR collection description, so you can see all the different data queries that are supported, as well as all the different parameters, their IDs, their names, their units, and the rest. So for this specific data set, we have a number of different variables which are made available through EDR. And to do an actual EDR query, then we would basically do a position query specifying the coordinates of -75 longitude and 45 latitude. That is roughly Ottawa. So here we can see the result of that, where the user gets back their map. This is again an HTML view, and being able to visualize one-to-many variables. So if we click on the actual point, we can see that we can also, in addition, choose which variables we want to visualize. So if I wanted to visualize air temperature, here you can see my graph. This came straight from the data of the API. And just to give you a bit more context, whoops, let's try that one more time. Oops. Right. So here you can see coverage JSON being returned as part of that EDR query. All right. So and that is basically what's feeding this user interface. But the idea here, back to the APIs, is that future rounds of work in WIS2 will have recommendations around APIs and how they should be crafted exactly, with regards to how naming conventions as well as behaviors for let's say EDR or maps for that matter. Thank you.
Any questions, thoughts? I forget what the question was, and did that answer the question that already came up? Was there a question that we were thinking might come up in the demo? Yes.
Yeah, my question was GM Villamilotero from Nestis. My question was, how do I know if the data set or the data that I'm creating, if it's WIS2 compliant? So I saw in the second slide deck that there was a tool for, I think it was like a metadata compliance checker or something. So I'm pretty sure that is the answer that I was looking for. So I just need to go download it and play with it.
Right. Though I don't remember that detail, but I know there's probably compliance checkers because there's rules about minimum amounts of metadata that you have to, supply to make the data as you publish the data. So there's probably compliance checkers for that as well. The metadata levels, level of compliance, and and I think, again, as was kind of mentioned, it can depend on the different areas that your data is relevant to, on what formats. Yeah.
Got it. Let me ask another question, if I can, if I'm able to. Is the WIS2 more applicable to the data or to the provider? Because I think that might help me understand a little bit more about this.
Is it more applicable? Okay. We have another running the microphone around. Thank you.
So my understanding as we're starting to evaluate publishing data this way is, if you look at, there's a WIS2 cookbook online that has example messages, and the standardization is really around the WIS2 transmission. The actual data itself, black box, can be whatever you're already publishing, which then ideally is meeting other WMO standards. But as far as the WIS2 transmission itself, we were talking, and you could theoretically be compliant by basically just publishing a message that is a link to your API somewhere else and almost nothing else. The rest of the metadata is just more information about how WIS should handle that.
Well, there is the metadata about each data set that you have to. There is a minimal requirement for what you do supply for a data set for it to get published. But yes, the data itself depends. At transmission level, right? You can send a bunch of bytes and whatever. No. Any questions online? Okay, I'm just looking at the chat.
Feel free to unmute and ask your question if you'd like.
Sure, I can ask it. I just threw it in the chat so it's captured. So when I started working, when WIS was coming into being, and even before WIS 2, my understanding was establishing a WIS 2 node could basically be done by any institution with approval of the WMO. And it sounds like your presentation say that this now has to be coordinated through the focal point of the nation where that institution lives. So who do we talk to in the WMO hierarchy to understand what the policy is for establishing a WIS2 node at present?
Yeah, that's a good question, and I guess I don't know the answer. I know that this is kind of centralizing things to WMO and moving away from, like, there used to be, we were in Region 4, and that's kind of that whole, I mean, I think the regions still exist and there's some structure there, but most of that is kind of going away in terms of some of the rules and stuff for particular regions. I guess if you know people in WMO, you can ask them about it. I do not know the answer, so that I will ask my co-conveners and see if I can get back to everyone. Which, by the way, in the agenda there is a link to a Google Doc, and I should have mentioned this at the very beginning. But if you can access that data, that Google Doc, and add your information to, there's a section for attendees, then I will be able to send everybody an email with some answers to these questions. So, and if you find out anything, let us know. But I will ask my co-conveners, and they're pretty connected and should know some answers. If you have any more questions, add them in there somewhere. So yes, I will look into that one some more. And I wrote down two other questions, which I can't remember right now, and I will ask about that as well. So maybe one of those two is this question. I think it actually might be. So, okay. Yeah, sorry, I don't have a more concrete answer. Yeah, it is pretty new. It's all kind of happening, and I know the Weather Service is scrambling with a lot of changes currently. So Weather Service is dealing with a lot of changes. So it's just a fast-moving, or at least uncertain time on how this will all end up unfolding. So.
Yeah, having worked with the WMO for a long time, if they hit their target year, I'll be amazed.
Yeah. Okay. Any other questions? Any other comments? Anything else I wanted to add? I just mentioned the Google Doc. So, oh yes, thank you for sharing the Google Doc link. So that's in the chat. And it's in the agenda, the meeting agenda for this session as well. There's a link to it. So for those of you in the room, if you're not at a computer connected, no, you can get to it there. But please add your names, emails, and I will let everybody know these answers to these questions, assuming I find answers. Okay, we have 8 more minutes before the session is up. Or no, 13 more minutes. Depends on which clock you look at. 12 or 13. That one's not quite right. Okay. Oh, no, it is. I'm just reading it wrong. Never mind. No other questions. Okay. Anything else I really want to say? No. What's that? Only I know. I don't think I know either. Okay, I guess we might as well wrap up and we can do whatever. Last chance. Questions, comments. How about, can we actually just go around and everybody say where they're from again? I'm Ethan. I'm from Unidata. We do real-time weather for university community, helping with data and tools. Sean, you've already said. Either John or James online want to unmute and say where you're from?
I'm James McManus, and I work at UNC RENCI, which is Renaissance Computing Institute. I work with a group there that works with the AdSearch storm surge model.
Ah, okay. And are you pushing data anywhere WMO related currently?
No, but I may get involved with a project in the Galapagos. So I wanted to kind of, I've never dealt with this WIS before, so I just wanted to get some level of understanding of it. So this was very helpful.
Okay, great. Good. Thanks. John online, John Allison, hi. You want to say hi? John's at NCAR, just down the street from me, or in the other office building. Anyway, he may not be. If you are talking, you're muted, but okay, he does a lot of Earth observing. He's in the Earth observing lab of NCAR and does a lot of data system stuff. And oh yeah, we can run the. Sure, I'll do it.
Okay. Can I introduce myself first?
Yeah,
I'm Kelsey Hulsman. I am an ESIP Community Fellow, and I co-chair the Biological Data Standards Cluster. And I am a remote sensing ecologist. I currently am in a postdoc at NASA Goddard. And I didn't know anything about this before this session, so it was very enlightening.
Great, and thank you for all your help. Awesome.
Sure.
We've already said it, and I can't remember.
My name is Andrew Yan with the United States Geological Survey's Water Resources Mission Area. I work a lot on cloud native data flows and data dissemination problems. I'm in the same building as the project, but it is rare that I work directly with it.
Okay. And you're interested in this too, is more of your data in this too, or?
Yeah, that's part of it. I think there are also asks from the weather service coming through Mike Mahoney, my colleague who's sitting across the room, and so scheming the technical milestones that we need to hit in order to meet the request from the NWS.
Cool. All right. Thank you. Thank you. You see, I'm not talking into the mic all the time. John, you want to say anything more?
I'll just say John Ralph, NOAA's National Centers for Environmental Information, and when I was at the previous office, the National Oceanographic Data Center, I wrote a WIS 1.0 compliant endpoint to support the Weather Service for the ocean data that we had there at NOVC. But I am not working on the current WIS 2 implementation, but sort of adjacent to the team. So I wanted to learn a little bit more about what they were working on, Weather Service, hooking up to our data and satellites, meta satellites.
All right, thank you. That's one of my questions that I'm going to ask is about archiving this data that's all like flowing in and they're keeping it for 24 hours at least. And then what happens? And Yeah, exactly right. Yeah, and I assume it's a national, more of a national thing than a WMO level. So, you want?
Yeah, I'll introduce myself again. GM Otero from NOAA Nestis. And yeah, I'm interested in WIS too because I do transition to operations, get data from satellites, generate EDRs, convert them into buffer to give them to the users, such as the National Weather Service. And I wanted to make sure that we were being proactive rather than reactive to make sure that as WIS2, which is already in operations, that it keeps going along, that we're not putting out fires.
Yeah. Yeah. That's why I'm interested, because we're going to be dealing with changes and need to figure out how to plan for it and how to transition our whole community to use these things anyway.
I'm Morgan Silverman. I'm at NASA Langley Research Center, Science Directorate and Atmospheric Science Data Center. And we've been doing a lot to align the NASA atmospheric science standards to the WIGO's metadata standards and adopt them or align what we already have to their standards. So I wanted to learn more about WIS2 kind of as the bigger picture that WIGO's goes into.
Hi again, Rebecca Hudak at WHOI. But the reason I was more interested in this is I work on a project called Science Rocks, Research on Commercial Ships. And we have a handful of commercial vessels that we've put meteorological instruments on, along with other scientific instruments that we get off the ship at a server at WHOI, but we'd like to, integrate it into more of a global product that is usable by folks. So that's the interest in trying to get my data into WIS2.
Great, thank you. But I was just talking to somebody last night about aircraft, and there's the ACARS thing, which is basically weather and other data on not all, but a lot of commercial aircraft, big commercial aircraft. Anyway, and those are all reported in and available through, probably go into WIS2 or go into GTS and are used in things. Anyway, so that's really interesting too, that, in terms of commercial boat things.
Mike Mahoney, USGS Water Mission Area. As Andrew's mentioning, I wind up being responsible for sort of publication of data from the observational network. And so we have WIS2 compliance, compatibility, integration as an item about 2 years out on a roadmap at the moment. And so, very interested in the developments around it.
Cool. Thank you. Okay. Well, that's anywhere. No. Okay. Thank you, everyone. That was really interesting, and don't want to get too close to that mic. Thank you for all the questions, and thanks for coming. I guess that's it.